Christopher, and I was trying to solve this puzzle that Mark did, and he used bifurcation, but I believe there's some more useful logic that you can use to solve this without any bifurcation. So let's see what we can do. So let's start with the obvious one. Let's start the same way that Mark did. I'm not gonna go through what that logic was exactly, but this one must be 3 or 4. And this one 5 or 6, 4, 5, 6, 4, 5, 6, 4, 5, 6. And this one is 1 and 2, like in the video. So, and these ones were 1, 2, 3, 1, 2, 3, and one of these had to have a 1 in it, and the other one is 2 or 3. And like Mark said, this one can be 2 or 4. These two can be 2 or 4, 3 or 4, or 2 and 5. So adding up to 6 or 7. So in both of the cases, these ones can be only 1 or 2. So let's put them in. And we have a 1 and 2 pair. Yes. And now, no. These ones can be only 2 or 3 or 4. Sorry, it can be 5, but let me explain why it can't be 2 and 5. So Mark used bifurcation, but there's a simpler way, I think. So this 8 diagonal and 9 diagonal, you don't have any common cells. So let's see what happens if we add them up. So if we add this 8 and this 9, we get 17. Now these two add up to 3 because they have to be different. These two minimally can be 1 and 3, so 4. 4 plus 3 is 7. But these ones must be 10, because you can see that if these are minimally 7, then these ones are maximally 10. And so they cannot have a 5. They must be the numbers 1, 2, 3, and 4. So let's remove 5 from this, and now we have a 5, 6 pair. And also we have to prove that these ones had to be the minimal numbers 1 and 3, because these ones have to be 1, 3, and 1, 2, 3, 4, and they cannot be any lower than that actually. So this one is 1, this is 3. Now we can have a 1, 2, 4 pair. Yes, okay. Yes, what we can do now? And this 3 now solves, almost solves it. This diagonal. This one must be 6. We can move 4 from this, and this one must be 6 now. Okay, we have 6s. Almost a sudoku. Now let's look at this diagonal. Like you see, this 5 and 6 mean these two must, the maximum they can be is 3 and 4. And the maximum this can be is 5. So 5, 3, 4, this is 12, plus 1 is 13. And we have another 4. So this one must be 4 or higher, but it cannot be 6. So this is 4 or 5. And similarly, if you do, the maximum is 5, plus 1 is 6, plus maximum 3 or 4, 6 plus 7 is 13. So this one also must be 4 or 5, because it cannot be 6. Now. And also, because the minimum of these two is 8, these ones cannot have a 1. So they must be either 2 and 4 or the 3 or 4. So let me 2, 3 or 4. So we can put the 1 into this one. This box. Oh, this cannot be 2 actually. Now the most useful logic is now, because it took me some time to find it, but it's not too hard. If you look at this row, then where can the 3 go? It cannot be in any of those, so the number 3 must be in here. and it has a tremendous effect on this column, because the only place a 3 can go is the 3, and these ones mean that it cannot be here, 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 and this cannot be 3, so this is 3. So we said that this is 3 or 4 or 2 or 4. It cannot be 3 and 2, because then it would be 5 plus 1 is 6, and 17 means these ones have to add up to 11, which is impossible now, because either of them can't be 6. So this one must be 4. Oh, and this 3 means these are not 3. This one is not 4, so actually this is 4. And this is 5. If this is 5, then plus 1 plus 3 plus 4, this is 13, right? So this one must be 4 to add it all up to 17. These ones are 1, 2 pair. This is a 3 pair. This 5 sources. This is 3. This is 5. This is 1, 2, or 4 from the row, but this one can't be 4. So this one must be 2 or 4. 1 or 2. This is 4, 2, 1, 2, 1. This one must be 4 because of that 4. 5, and this one also is this one. Okay. And now we almost have it all. 2, 3, 4. This one must be 5. 1. Okay. Now this one must be 1, 2, and 1. And now we have a deadly pattern of 2 and 3, but of course we haven't used this 9. So if you use this 9, then 4 plus 2 plus 1 plus 4 is 7. This one must be 2. And voila. That's, I think, maybe the easiest way. There was also the possibility of using an X-ring of 2s to get the 1, 2 pair in here. Maybe that would have been also a possibility. So either way, it wasn't, it didn't really need bifurcation, but I really love the trick about these sum of 8 and 9. It was quite a big revelation for me, because it solved 2, 5 not being possible, and the numbers 1 and 3 at the same time, so it was quite lovely. Okay, I think that's all. Okay, bye.